Okay, sounds good. So Mauro is a software engineer at Google. In a past life, he used to be a physicist at CERN. He's also done his PhD in theoretical physics, and so lots of machine learning, lots of physics. The reason I'm introducing the judges, by the way, is so that you can use their expertise in guiding your projects. I think this class has resulted in a bunch of very cool projects, and I think you need experts like these to talk to about your work, present your work to, and get some perspective on where you could take this work. So, Mauro Varzati, everyone. We have Aishwarya Kamath, who is a PhD student at NYU Data Science. Previously, she got her master's in computer science, if I'm not mistaken, from UMass Amherst. She's working with Jan LeCun and Kyungin Cho, and she's got significant experience working at various companies, including internships at Google AI and Facebook AI Research. And if I'm not mistaken, she also worked at Oracle.
Oracle's machine learning for you.
Expert. Cool. Thanks, Ashwara, for joining us. And last but not the least, we have Karan Davalia. Karan got his undergrad at Carnegie Mellon University in ECE. He then joined Clumio as a member of technical staff. Spent a couple of years in Silicon Valley, building up the company as they emerged from stealth. And eventually, he now is the founding engineer at Octane, which is a budding startup comprising of CMU alumni, and they're doing very cool things. So take a look at what Octane does. Welcome to all of our judges, and thank you again for being here. With that, we can now go to the amigos. Take it away.
So good morning, sirs and ma'am. This is our project research paper recommendation system, mainly using document level embedding. Now, before we get in,
sorry, really sorry about that. Give me one more minute. Akash doesn't seem to have the link, so he is there, but give me 1 minute to get him.
Sure.
Thank you. That's a great point raised. I should probably go with the grading rubric as Akash joins us. So the grading rubric has been designed keeping in mind that you've had a couple of weeks to pursue projects, and most projects aren't at the end stage, but at a good stage of progress. So you will be graded according to the work you've done and the experiments you present. So we have intellectual merit, which holds 30 points, which is answer to the question, how likely is this idea to contribute to or advance the field? We also have another 30 points for execution or a discussion of your experiments, where we will talk about whether your experiments are scoped out well and results are analyzed meaningfully. The rest of the 40 points out of the 100 points are for your presentation, where we will look at the content of your slides, we will look at the quality of your presentation, we will look at the Q&A. And so that's 13.33 points each, which is not ideal. But yeah, there you go. So we will also post a link to the rubric in the channel in case you want to take a look at how you're being graded. But with that said, if Akash has joined already. Cool. So to introduce Akash Srivastav, a lot of you already know him. He's been a stalwart for actually launching Unicode research. Akash is a staff research scientist at MIT, IBM Lab. He works on deep generative models and previously got his PhD at the University of Edinburgh with Charles Sutton. So Akash has really been like a mentor for me, a mentor for most of the TAs who have been at Unicode research, and we owe a lot to him. And thanks for being here, Akash.
Also, thanks for the intro. Really sorry for not being able. I just didn't get the Zoom link.
No,
I
that's
couldn't
fine.
find it. I'm really sorry for being late and having you repeat all the rules again. Apologies, everyone.
Thanks a lot. And let's.
I just say one thing. When they start with the presentation, can they also say what's the name of their team, because their actual names are not on the rubric. So
yeah, I'll also announce teams before they start, so we should be good. We are starting with the amigos. So their name should be on the rubric, by the way.
Yeah, but not over here, like
okay.
Current screen.
Sorry.
So, thanks.
Take it away.
All right. So good morning, sirs and ma'am. This is the amigos, and I am Karan Davalia. This is our project, research paper recommendation system using the document level embedding. Now, before we get deeper into this, I would just like to point out that 2 of the members of our team aren't here today because of other personal commitments. Owing to that, I'll do my best to give an overview of what their focus was in the project as well. However, maybe detailed questions would not be answered if those arise relating to their topics. Sharik is here, however. Sharik and I worked on the code implementation of this project and collecting the data set. So aggregating the data set rather. Right then, so if there's no problem, we'll get into this. Right. All right. So this will be the flow of our talk. I'll be walking you through these points, which is the motivation for our project, the main idea, the existing research we've looked at, our methodology, our progress so far, and our hypothesis going forward. So the motivation here, of course, this being a research paper recommendation system, was that there's been an exponential rise in research papers being published recently, and accessing the related documents is a monotonous process. So we are looking to simplify the literature review process in all this. And our aim is to get relevant citations of the related papers for the researchers who are looking into these various topics. Now, as for what our main idea is, or the steps that we are taking or dividing this project into, is that first we are using a language transformer or a sentence transformer, using that to get the document embeddings of research papers or specific components of the research papers, and generating an n-dimensional embedding. After that, we are getting the cosine similarity of. I'm sorry, is there a problem? I couldn't hear what was being said.
Someone might have accidentally unmuted. You can go ahead.
All right. So getting to the cosine similarity, we'll be deriving a cosine similarity, which is mainly done through the pre-trained models. Cosine similarity will be with the queries that are generated from the user input. And the final output is the top K results of recommended papers. Here we see an overview of Spectre, a pre-trained model which we are using in the project. So the existing research that we looked at, that firstly includes the work done by Haruna and his team. So this was basically a contextual metadata-based algorithm, a heuristic algorithm more precisely, that gave the top N recommendations for research papers. The evaluation metrics that they used were given as such. So precision and recall based on the relevant papers and the total retrieved papers. The relevant papers were calculated based on the rank on which they were retrieved. And finally, the F1 score. So they made progress compared to the work that had been done before them. The progress is shown in blue, that is their metrics shown in blue versus the previous works. And it had drawbacks which were stated in the paper itself. First being divergent techniques papers. This mainly refers to the fact that a researcher might want to look into a topic, but not necessarily constrain himself to a particular technique. So an abstract that he might give as an input might have one particular technique, but the researcher might be open to other techniques. And such results are not given by this work, since it is purely based on relevancy metrics. And we'll try to improve on this. However, the second point, which is relevance or preference score, this word does not output as well. So again, it calculates the rankers based on their data set, and that's how it gets to its results. Hence, it does not output the relevance or preference score. We are surely doing that. We are outputting the score that the similarity gets based on the queries and our data set. Moving on, we also looked at archive neural search repository. It's on GitHub. It's not a published paper. However, it's similar to what we are doing. What it does is uses the categories and abstracts of papers for a similarity search. The data set that they're using is a Kaggle data set for archive metadata. They are using FACE for indexing. It's a model that's a subset of the SimCSE model, which is a contrastive learning model. And they're using Distilbert for the generation of query embeddings, that is for the input data.
What did you say was the subset of SimCSE again?
So FACE.
FACE
indexing.
is a thing by itself. You can use any similarity metric that you want with it. Like it has, FACE is like from Facebook, and it was built for large corpus indexing. It doesn't have like anything specifically to do with just SimCSE or like any contrastive approach. Just to let you know.
All right. Well, that's a fault on our part.
It's
Fair
fine.
enough.
It's not
Yeah.
a big deal. I'm just letting you know
Yeah.
so that you don't. Yeah.
Well, it kind of played a big part in our research then. So anyway, we'll get to it then.
It's just a library, so it's fine to use it. It's a very good library.
Okay. So, well, anyway, here's a demo of that repository as it's given on the repo itself. They are basically entering the abstract of the paper in the search field, manually selecting a category, and then recommendations pop up accordingly. This is what they're doing. And yeah. As for our method, this is our pipeline currently for data pre-processing at least. So we are taking the same archive metadata dataset from Kaggle. This dataset basically contains the archive IDs, the titles, the abstracts, author names, etc. Of those, we are using the archive. So, right, I should get to this first. The solid arrows represent what we'd like to do ideally, and this dotted arrow currently represents what we are doing. So going for the ideal way right now, we would be extracting the archive IDs from the archive metadata dataset, putting those through the archive export API. So basically web scraping and getting the PDF files of those papers. That dataset will be passing to a PDF to text converter, getting the text file sentence, then pushing those through a sentence transformer and getting the document embeddings to get a final dataset. That's the ideal flow that we would want to follow. Of course, we are getting the whole text file because we think it would provide more accurate results as opposed to just the title and abstract. And currently, we are just taking the title and abstract present in the metadata and passing those to the sentence transformer to generate embeddings. So that's regarding that. Then moving on to the inputs that we are pushing in. This is again the ideal case which we would like to go towards. Our pipeline would be taking the title of the paper or the archive ID as the input, sourcing the actual paper ourselves through, again, the archive export API, going through the same data pre-processing pipeline, generating the query embeddings for this one, calculating cosine similarity, and then generating the top K results. And the pre-trained models for this process that we looked at are obviously in the contrastive learning process, SimCSE and Declutter. we were focusing on SimCSE because the paper itself mentioned one of its applications that could be possible as research paper recommendation. And this is simply how SimCSE, the supervised version of it works. And we are obviously, again, using the supervised model ourselves. Yeah. So, yeah. SimCSE here, it's showing an example. So if we input the embeddings for two dots running, it would show contradiction or entailment that is positive. Yeah. So positively correlated embeddings or negatively correlated embeddings that way. However, yeah, we went on to the assumption that SimCSE was being used in the archive neural search repository, which is why we changed our focus to the Spectre model. And the Spectre model was shown before. It uses Cybert transformer inside of it to generate the document embeddings. Why Spectre? Because this paper too shows one of its main applications to be specialized into research paper embeddings. So that is why we are using Spectre.
Can you describe what the SimCSE and declutter models look like? Like this, I can only see that there's some text being input and you get some embedding, but like what's the structure of the model?
Yeah, that I would not be very knowledgeable of. That research was again done by mainly Akshay and Anant, and they're unfortunately not present. And unfortunately, I do take the responsibility for this for not being informed on that.
Okay.
Yeah. So our progress so far has been this. We've passed around 5 examples, right? So getting to the data set that we've used first. We are currently considering the embeddings for around 100,000 examples or 100,000 samples of papers from the archive ID data set. And using that as the base data set, we have now passed 5 test data which are not present in the main data set. And we are getting the recommendations for those, along with the similarity score along with it. So we are getting the top 10 recommendations from the code that we've written. We are inputting the title here and the abstract for the Spectre model. Similarly, we have another example on similar basis. It gives the recommendations along with the score. Now, yeah, for our hypothesis, it's mainly focused on the evaluation since we haven't done any numeric evaluation of our own work yet. What we are planning is use overlapping citations in the target and recommended papers. So this basically refers to if both the papers, that is the one being queried and those that are being recommended, have the same set of references or similar references, that contributes to the similarity or them being in the same domain. Then count the common citations, normalize the scores along with the number of citations, and then find a threshold of correctness for the result. So again, from the numbers that would be generated, we would again heuristically consider which of them are really similar and which of them aren't, and a corresponding score for that. And then finally calculate the accuracy of the recommender. Now, this is a similar triage that's been used for Haruna's work in his paper. So in that too, they evaluate on a similar basis. For relevancy, of course, they consider the rank. Here we would be directly considering the overlapping citations for evaluation. And our main aim is to achieve better results than archive neural search. Now, while we see that archive neural search again isn't published, so it does not have numeric evaluation for its results. However, we could compare the results for what we get. And yeah, for references, this is what we followed. So Haruna colleagues work using the heuristic algorithm, archive neural search, declutter SimCSE, and the Spectre model. All right, so that was it for the presentation. Sharik and I would be open to what some questions, I suppose.
So I'll open it up to the judges first, in case they have questions, and then I have one question, please.
I guess I have. Well, okay, go ahead. I already asked a few, so you.
Oh, no, absolutely. Go first. It's totally fine. Yeah.
Yeah, I guess to make this more compelling, you would you have a bunch of different models that you talk about, like SimCSE, Declutter, and Spectre. From what I understood from the presentation, the last one is the only one that uses bioarchive or uses Cybert, sorry, as a pre-training data set, and the other two don't. So I guess you would need to show some sort of actual analysis based on if you use certain data set, what kind of scores you get and what benefits you gain from a particular data set, so that going forward, you need to improve upon whatever you have right now. So you need to make sure that the last to piece apart the modeling from the data is what I mean. So I think it's important to figure out which is the thing that's contributing. Yeah. More of a comment than a question, sorry.
I think more on Akash.
Akash, please go ahead.
Thanks. Thanks again for it was a really great presentation. I really enjoyed it.
Thank you.
I don't have so many I don't have any comments, but I just wanted to ask a few clarification questions. I'm not very familiar with the subject matter, so I couldn't really get the difference, or I think you mentioned about the Spectre model, and I couldn't really tell what things are different in the one you're proposing. There was some evaluation in the beginning, but towards the end you said there is no evaluation. So I'm a little sort of confused. If you could just go to those slides just to kind of clarify something.
Sure. Next. Yeah, right. So I suppose this one first.
Yeah. I think that was the one after this or before, somewhere in the neighborhood of this. Yeah. So here, yeah, just the one before this. When you say you're sorry.
The one before this.
Yeah, the one with the plot of
This
your
one.
proposed model being evaluated against. Right.
So this isn't our proposed model per se. This is Mr. Harana's work done with a heuristic algorithm in their paper, and this is their proposed plot. So the F1 score that they're getting compared to their metrics.
Oh yeah. Maybe that's what confused me, because I thought you do have some evaluation here.
No.
Yeah. So is it correct to say that currently you're using Spectre model as the base model, and okay. Yeah, that's all I wanted to know. Thanks.
My question is basically on the same slides. Later in the presentation, you say that you would like to build a new data set and basically evaluate your model against citations, basically creating a data set based on citations and cross citations. But why don't you use these public data sets first? Is there something wrong with that? I mean, if this is referenced, why don't you just put that point in this plot with your stuff? Is there something wrong with that?
Nothing wrong with it necessarily, I suppose. Just gathering the data was a problem. So archive was the most openly available, I suppose, but we could look into it.
These people have not.
Yeah, the fact that we just
this paper hasn't released their data. The Haruna, I guess that what he's saying is, if this already exists, why don't you just report on the benchmark that exists instead of?
Exactly.
Right. So their metrics are slightly different. So they're calculating on relevancy basis. Again, let's go.
The main issue for us not selecting their data set was mainly due to the computation constraints which we have, because none of us have proper GPUs to run these models, and the on the large data set. So that's why even the data set which we have chosen, initially there were 2 million papers in that, but then we had to cut short to 100,000. So that was the main issue for that.
No, it's a totally valid answer. And yeah, I mean, you could just even try, as you said, to downsample and to refer on to that sample so that at least we have a benchmark. It's easier to compare. Because otherwise, if you put a benchmark in the void, it's always hard to say which is better, if you did something better, if you did something worse. Instead, if you refer to some benchmark models or some benchmark datasets, then it's easier to show improvements.
Or you could
Yeah,
also
noted. Thank you.
like if they've released their code, you can release their method on your subset, and then that's a fair comparison as well. Because if you're trying to like submit this at some point, you're going to have to prove that it's doing well, and doing well on your own data set is not going to be as convincing as when you have a data point from some other papers that you can compare to.
All right, noted. Thank you.
Saying you also mentioned the Kaggle challenge dataset that might be smaller, and you might have some better chance with that.
Okay.
Currently, we do use that data set. Yeah, I think, yeah. But yeah, we get the point that we need some benchmark to compare both the results, I guess. Yeah. Thank you.
Yeah. Again, the Kaggle dataset had 2 million samples, and we are taking it down to 100,000 for this one.
Karan?
Yeah, hey guys, good presentation. I had a couple of questions around the evaluation. So one of the drawbacks that you mentioned in the Haruna paper was the fact that, divergent techniques were not, evaluated correctly because of the evaluation metrics. So what I was confused over, or maybe you glossed over the fact that, is that one of the drawbacks you were tackling with the proposed technique? Or because you said you were going to only evaluate based on the same sort of evaluation metrics, and it doesn't take into account divergent techniques. So I was wondering, what was your evaluation process?
So it had 2 drawbacks, and I said that this one would be surely not tough, and we are presenting the similarity score in our case. Divergent techniques is still a bit tougher. However, we are looking into the fact that we could set certain thresholds which we could analyze over the data. So maybe, let's say, very similar papers which are constrained into the same topic plus the same methodology have a very high score, as compared to divergent techniques, which might have a lower score, but then we'll have to look into that. But the second point is the one we are tackling precisely. The divergent techniques point is tougher.
I think what we tried to do here for our evaluation was try to introduce overlapping citations of both the result and the input to come up with a threshold number to give a better score to related papers on the same techniques.
Okay, got it. Could you go back to that evaluation slide?
Yeah. This one?
Sorry, okay, yeah. Sorry, it wasn't loading on my computer, but could you go back to the evaluation slide? No, your evaluation. Yeah, not the Haruna one. Your evaluation.
Oh, okay.
Okay, got it. Okay, awesome. Thank you.
I'll just quickly say, I don't know, this is just like on a related note. I don't know if you've seen this website called connectedpapers.com. Maybe you can like just use it for inspiration. It's basically a recommender system for papers, and it was made, I think, by some PhD students a couple of years ago, and then they made it public. Like it was like a private thing. It's extremely like high precision for me. Like I find it like very helpful for related work and things like that. Like it gives you relevance by many different factors that you can choose for, and gives you like, especially if you're starting new in a field, it's useful because it gives you the high impact papers in the field over the years and things like that. So yeah, maybe something to take inspiration from since it's doing so well.
Okay, noted. Thank you.
All right. So so clearly now we have a precedent and the judges are basically your reviewers. And so the comments are almost exactly what a reviewer would tell you if you're going to write a paper about this. So please use the feedback accordingly. And thank you so much for engaging so much. This was very nice. With that, let's go to the next team, ML Scouts. Gaurang, if you could
Yeah,
yeah.
Just a minute.
So we'll ask the teams to keep it to under about 9 or 10 minutes, if possible. Again, the more time you save on your presentation, the more the judges have time to give you feedback. So,
yeah, Swapnil, for Team ML Scouts, could you make me the presenter, Shrey Parekh?
yeah, sorry for that. Should be good.
Okay. So wait, I will switch on my cam. Am I visible and audible?
You're visible and audible, yeah.
Yeah, just a minute. I'll start share. Just a minute.
Yeah.
Yeah, is the screen visible?
Screen is visible. Do you want to start presenting?
Yeah, just yeah, my teammate Devang is available, right? Devang?
Yes, I am there in the meet.
Okay, cool.
You should start.
Cool.
Yes.
So we'll start presenting. Yeah, thank you. Okay. Good evening, judges. We are Team ML Scouts. We are here to present our project. We are a group of enthusiastic first and second year students who had almost negligible knowledge about machine learning and computer vision throughout this course. But we learned a great deal of things and developed an interesting project applying that knowledge in this field. We have something about the project. We have created a flag classifier. Let's discuss more about our idea. So just a brief. Flags are not easily identifiable due to their non-rigid characteristics, especially under conditions of deformation, obstruction, or changes in light intensity. So we came up with a simple idea. What if we find flag images, put it in a model, and which detects such a flag and segregates them according to its respective country? Upon more research, we realized that flags are a great deal and have a wide variety of applications. Some of them being like flags can be used in overcrowded places where like in protests or riots where people show support using flags, or even in sport events, like flags can be used in Olympics, Commonwealth Games, or football matches. They're like found everywhere. Implementing such a model where we can just detect a flag and classify that flag according to its country, it's very beneficial, and we can just not only a single flag, but we can detect thousands of them in the crowd with just a single scan. Flags are used in international programs like UN or SARC conferences, where flags of different countries, like different attending countries, can be identified. Placards and badges can be detected in important UN meets and numerous exchange programs, cultural events, thereby saving time of manually looking up info of that country. Some miscellaneous uses of flags are we can literally find flags anywhere on stamps, currency notes, banners, t-shirts, important documents, image detection. So like important documents. So like image detection and classification can help in all of these sectors. For this project, we took up 8 SARC countries, which are India, Bangladesh, Pakistan, Bhutan, Nepal, Sri Lanka, Afghanistan, and Maldives. Their flags have not been worked on in any project before. Other projects have gone for almost 15 to 20 popular countries. Most projects have used different architectures, and this is our go at it. So like our basic idea is to take a flag, put it in the model, and just detect the flag according to its country. So some of the libraries which we used for our project are Augmentations library for the augmentation of flag images. We use the Torch Vision library for loading the pre-trained ResNet model, and of course for image detection and its classification. We use the OpenCV library to deal with the live images and videos. Other libraries which are pretty self-explanatory to deal with images are PyTorch, Pill, and NumPy. And so we'll discuss each of the library in the further slides too. The platforms which we used for this project was Google Colab and Google Drive, and somewhat VS Code also. So let's talk about augmentations. We'll also talk about how we collected our data. Like a ready-made data set for a wide variety of flags was not available anywhere. So we manually scraped the web and gathered the flags. Also, rather than taking up too many flags for our data set, we focused on 8 Asian countries, which I mentioned earlier, and applied augmentations on them. So we augmented the images to include resized, reflected, rotated, and many more versions of the image. We have abundant static images for our training set. We have around 3,000 images, 3,000 plus images for 8 of the countries altogether. And for the dynamic images, we took videos of SAARC countries to test the model's prediction with dynamically added frames. So this is done to improve the robustness of the network, and we got to know a bunch of things on how to manipulate images using Augmentations library. So here are some snippets on how we implemented the same. As you can see on the top left, we tried applying one transformation on multiple images using image function of the Pill library. And on the right, we use the compose function of Augmentations library to apply multiple transformations on multiple images at once. So these were the respective results on the left and right respectively. Moving on, something about our model. So first of all, here is a sample visualization of a data set. The first line here is like below the picture, you can see is most of the countries which are covered and their visualization. And moving on with the code. So in the first line, we loaded the pre-trained ResNet 50 model from the models available in the Torch Vision library. We changed the number of classes to 8 since we are dealing with those 8 countries. We put the model onto the device for running. Here we have used cross entropy loss as our loss function and Adam as the optimizer. So the basic idea to use Adam was because the convergence is faster and our runtime gets quicker. And obviously cross and entropy loss upon trials, we found this to work the best, which my teammate will explain further. And okay, yeah, that's about that. And moving on, my teammate Devang would like to take over. Devang.
Yes, Sri. Thank you.
Yeah,
Good evening, everyone. I am Devang Shah, and I would continue with our presentation on flag classifier. So here I have presented on choosing the right model. So here we have experimented on various different types of models. The first one was the ResNet 18 model with the Adam as an optimizer. So it gave us an accuracy of 0.74 something. In a span of 8 minutes 15 seconds it took to run 20 epochs. So next we tried the same ResNet 18 model but SGD optimizer. So the accuracy changed to 0.73 and it took about 8 minutes 43 seconds to run 20 epochs. Same with the Adagrad optimizer, the accuracy dropped down to 0.62 and 10 minutes 40 seconds for running that epoch. Next, we thought of changing the model. So we thought of adding more layers that can increase an accuracy. So we thought of using the ResNet 50 model. The same thing we did with the optimizers. First, we used the Adam optimizer, then we used the SGD, and then we used the Adagrad. And the accuracies and the times are as displayed. So from here, I can easily conclude that the ResNet 50 model with the Adam optimizer, which gives an accuracy of 0.77 and took a time of about 9 minutes 56 seconds, is uh, somewhat more accurate to our model in terms of speed and accuracy.
A quick
Next slide.
question about the size of your data set.
Yeah, so we had around, we manually scraped out 50 images for around 50 images for each flag. Then we, for each flag, so for 8 flags, it came up to about 400 and 450. Then we performed augmentations on it and expanded it to 4,000 images. And then we split it into 3,000 and 3,000 train images and 1,000 validation images and 2 test videos.
Okay. So the size of these data sets is still considerably small. So when you report accuracy like this, you need to report it on like multiple splits of the data or like multiple runs of random seeds. Because when you say like you're trying to compare between different optimizers and look at the time, yeah, whatever, doesn't matter, but like it's good to get a sense of it. But if you're like trying to choose between different optimizers and models based on like these scores, it's a bit like finicky to decide based on just one run because your data set is so small. So ideally you would have like many runs on different splits of your data where you hold out different like you train on some subset and you evaluate on another, which is called cross validation, or like, and in addition to that also, you would, for each of those, you need to run them at least 5 times so that you get like results which are more robust as opposed to like just from one run.
Okay, I got your point.
You report like the mean and standard deviation after that.
No.
In general, yeah, continue.
Okay.
No, while I use this interruption to ask another question.
Yeah, no problem.
When you fine-tune your model, do you fine-tune the whole ResNet 18 or you just fine-tune the last layers, the first layers? How does it work, this fine-tuning?
No, actually we have directly used the pre-trained model.
But you update can you go back to your page with the code, the slide?
Yeah.
Yeah, so it's only the FC parameters that are being updated.
Yeah, the last parameter. Yes.
The second last line says only the.
Yeah, we just manipulated, like here we have mentioned with pairing with the learning rate and all. So we tried like 0.
Yeah, not that. So basically, to your optimizer, you're passing in parameters of the model. And you at this point you're telling the like optimizer which parameters of the model you want to update for on this data. The rest of them are not going to change. So you can consider changing, like here, basically all you're learning is a linear classifier on top of your pre-trained model.
Yes.
So you can also think about updating like, the last 2 layers or something, which might give you some more boost. But yeah, you probably don't want to fine tune the whole thing because your data set is really small. So you'll get like pretty bad validation accuracy if you try to do that. But you can try like fine tuning the last few layers with like a lower learning rate or something.
Okay.
Yeah, okay. Got it. Point. Thank you.
Should I go on?
Yeah, thanks.
Yes, let's. Should I do how? Okay, next slide. Yeah. So the next step in our project is to use our model in classification of videos, that is our test data. So OpenCV library was used to capture flag images from the webcams. Here you can see these are our teammates holding the flags in front of the webcam and capturing the videos. Then we converted those videos into frames. And then the frames in the JPG format can then be fed into our model so that the model can predict. So here we see that it's predicting Bangladesh and Bhutan accurately, and similarly for Nepal. So this is completely done on the OpenCV library, and this proves that it can work on dynamic data and videos also. Next slide. So now let's have a run through our model. So on the right, we have displayed a demo where we ran the model on 20 epochs, epoch 0 to 19, which means the model has passed through the dataset 20 times. With each passing epoch, there is generally an increase in accuracy and decrease in loss. At the end of 20th epoch, the time taken, the best validation accuracy, and the best training accuracy are printed. So the best validation accuracy which we achieved was a 0.77, which means about for 77% of the validation data, it predicted the correct class. Initially, the loss values were high, but after some epochs, the losses fell and converged to a constant value, which is shown in the loss plot to the right. The blue one is the training loss, and the orange line is the validation loss. So here is the accuracy plot of our model. Similarly, we have training accuracy in blue and the validation accuracy in orange. One notable thing is that there are no spikes in both of our plots. This is because we tried to resolve the problem of exploding and vanishing gradients. Then on the right, we tried to visualize and display few of our model predictions on the validation data. So here are the results. Like for the flag of Afghanistan, it predicted Afghanistan. For the flag of India, it predicted India. But here there is an error. For the flag of Pakistan, it actually predicted Maldives. Rest all, I guess, are correct. So around 9 on 10 flags were identified properly.
That's in your training set or on your validation set? Because your validation.
No, this is the validation.
Validation.
Okay. I mean, your plot says it's like 70% on validation, which is what I was wondering.
No, we have just plotted 10 model predictions, and
okay,
the best one we have printed it on our PPT just to look much better. Sorry for that.
So this was
no, that's fine. It's okay. I'm glad you show like positive and negative. It's fine. I was just curious because this is not a random sample then, right? This is a cherry pick.
No, validation. Yeah.
Okay, cool.
So talking about the future scopes of our project, so we can obviously an Android application can be created which uses the mobile camera to detect and identify the flags at various use cases which Ray explained in the first and second slide. Also, we can create an object detection model on the same, which actually predicts, which also says you the exact location where the image is located in the entire image, and also can predict multiple flags in a single image. And when a country's flag is identified, we can also present a fun fact or the current news of that country alongside with the name of the country. Also, identifying symbols and text embedded on top of our country flags can also be a future aspect of this project. And one future aspect can also be the model which we have worked. Someone if tries to reuse the model and tries to increase the accuracies, even that could be a future scope of a model. Okay, so actually this was our first hands-on CV project. We had no prior experience before this. This was a challenging task for us, but it was a great project for us to get a taste of computer vision, machine learning, and deep learning. Thanks to Swapnil and all the TAs who were quite patient and showed us support, and additional feedback and improvements from your side are also appreciated. Thanks to one and all.
Also, thank you, judges. About like we'll try to play with the last two layers of the pre-trained President 50 model also, and I guess we can get better validation accuracy also. So we'll take your point in mind.
So I'm going to ask the judges to keep it short, particularly because I mean I have time, students have time, but I don't want to take up too much of your own time. I'll move to judges' comments. Now you can go ahead.
Very quick question. When you said you were splitting your dataset in training and testing, is the training and testing taking care that basically you are starting from the same 40 images? So like you should split, how is the split happening? Because that could create some biases.
No, actually what we did is we collected those 50 or 60 images which I told earlier for each flag, and then at that point only we splitted them into around 45-15 or maybe 40-10, something like that. So the validation set was completely different and the training set was completely different.
That's great. That's great to hear. One last thing, very quick, as a suggestion, if you are struggling for computing power, given that you are only training basically one layer while you are feeding basically the full image, what you could do is to separately run the images through the model, pre-compute all the embeddings up to the layer that you want to optimize, and then only optimize the layer. So it basically shrinks the image size to something negligible, and then it's super fast.
Okay. So we had an image of 256 cross 256. So yeah, we can obviously crop them out.
What I mean is that given that you have your whole ResNet, what you are doing during optimization is that every time you are going from the image through all the ResNet just to optimize the last layer. If you pre-compute all the ResNet information up to the last layer, then you can just optimize that, and so you have an embedding that is like 512 floats. And that's
okay, I got you.
Even on, I mean, you could do it even on device if you wanted to.
Yeah, you are correct.
We can Karan and then Akash. Oh, sorry. Go ahead.
Wait, sorry, Mario, do you have a follow-up?
No. I just wanted to say that I was done so that we save as much time as possible.
Yeah, guys, great presentation again. I just had a couple of questions regarding the assumptions made in the start. So this is just general feedback. As you started off the presentation making, this an array of use cases ranging from, videos with multiple flags in it to, other use cases I don't remember exactly. What would have been helpful is to actually, have a slide where you're stating the basic assumptions that you're making. One of the things that I thought was slightly glossed over was the video processing part. You guys held up an image in front of a camera and took a video of it, which technically just translates to an image frame, which is what you did on image models also. Something more interesting would have been a video with more noise in it. So where, one frame is not enough to actually formulate the entire image, and you have to do some sort of more processing to actually reduce pixel noise by calculating multiple frames and figuring out what the image was. I'm not saying that what you guys did was, not cool. It was awesome, but it would have been better to start off with a very basic set of assumptions and then build on top of it instead of starting off with a wider use case and then digging into one thing. So yeah, that's just general feedback, but.
Yeah,
we would consider that also.
Here's the definition of considered: having.
Apologies. I think somebody said considered. Thanks, sharing the map. It was a great presentation. I really liked it. And brilliant work on especially how you went through explaining your data collection and pre-processing. That's usually, nobody mentions that. I'm very impressed. Like I mean, at least from what I can see, it was very well thought of, and yeah, you really did. The pipeline is very good. I think overall, I genuinely liked it. My one question to you is, so when you were showing the results, do you have any idea, any notion as to why you're getting or stuck around only 74% or 76%? Do you know why, when the things don't work, like in the case of the Pakistani flag sort of being misclassified? Why do you think that's happening? Or is there some shape bias in the Nepalese flag that is firing it because it looked like slightly skewed. What's your intuition for that?
Shrey, you want to go?
I guess I may be wrong, but like in our training data set, we may have involved, like we may not have involved much of crowded images. Like we just have put in some pure images without any noise or something. And in validation data set, those images may have come up. So they may be showing a bit less accuracy. I guess that may be the problem, but we'll check out further. Like we'll go a bit more into
Yeah,
this.
similar intuition from my side also, that maybe our validation data set can be a bit difficult than the training data set.
Right. So maybe just something to think about then, like why exactly is your model failing on the set it's failing? I mean, definitely one of the things that I think other people have mentioned is that the amount of data you have is probably pretty low. And yeah, just to sort of think about why is this thing, because you did go through the extra step of actually looking at the misclassification. So it's just the right direction to move and to understand where the model is failing and then fixing it. But otherwise, like, really nice work. Thanks.
Thank you.
Thank you so much.
Awesome. So we can move on to the next team, which is UPS. Thank you. UPS, are you around?
Yes, I'm here. I'm just setting up my camera. Yeah.
Gotcha.
1 second.
So while they set that up, so the team after is going to be the namespace. So by the time the teams start like Q&A, please prepare like your videos and your slides and screen sharing.
My video is not working, so I'll be doing that without. It's cool, right? It's giving me an error.
Sounds good.
Yeah, cool. So I'll just quickly share.
It was on for a second, but yeah, that's fine.
Yeah. It crashed in once.
If you want, we can swap around order and we can move on and we can come back to you.
No, it's fine. It's fine. I'm just getting things ready.
Take it away.
Yeah. Presenters, yep. Let me know if it is visible.
Slides are visible.
Perfect.
And you're audible.
Perfect. So yeah, good evening, everyone. Good evening, judges. Good evening, Swapnil and every TA here. This is UPS team. I'm the sole member of team Sarthak Ojha here, and I'll be showing my work, or rather my approach to the topic on image super resolution by using denoising diffusion probabilistic models. So before quickly going on to why I took such a weird model to work on such, already worked on use case, I'd like to quickly share my motivation example here. So DDPMs took up a massive, surge of popularity in 2020 in the field of text to speech. And I had taken on a project specifically in the field of text to speech, working on Indian speech data set. Now, by default, there were no data sets, so I had less than 4 hours of data. And I had to quickly submit a model in a couple of days for my final presentation to my professors. And I didn't have compute apart from my laptop. So in desperation, I go to Mozilla TTS. That's a very big community on text-to-speech. And they recommend me something known as WaveGrad, of which graphics you see right here. And this model was able to converge in just 4 hours of data, giving me an excellent result. In comparison, none of the GAN models were working. So as I entered into UMSC, I decided that I will work on super resolution by using DDPM just to see what new things that I can look at it. It so happened that as I was working on it, I was initially using the research paper by OpenAI, that was DDPM's beat GAN in image synthesis. But as I was submitting my work to Swapnil, Google produced that research paper in forms of 2 papers, that is cascading model and SR3. So my work builds up on that and continues down the line. So before quickly going through all of the research papers and all of that, I'd like to quickly discuss a little bit about DDPMs. Now, diffusion models are inspired from nonlinear thermodynamics. They are from physics background. And they basically are a, they can be defined as a Markov chain of diffusion steps. And we slowly add random noise to the data. After doing so, we then reverse the diffusion process to construct the desired data samples from the noise. So the way I like to think about it is that you make a mess out of the image, and just like CNN slowly and steadily learns every, layer by layer, it learns from lower level features to higher level features. Similarly, a denoising DDPM model basically learns from reconstructing lower level features, slowly and steadily getting the image back. And the difference between a DDPM and other models like VAEs or flow models, for that example, DDPMs are learned with fixed procedures and their latent variables have really high dimensionality. As you can say, it is as same as the original data. So before we continue, this is a quick comparison between major of generative models. As we can see, there is GANs here. Oh, one second, I'm so sorry. There is GANs that basically use a discriminator, then rate that discriminator and then pass it through a generator. We have VAEs that maximize variation by lower bound models. Then we have flow-based models here, which basically invertible transforms. And then we have a DDPM that basically makes some, adds Gaussian noise and then reverses the entire process, right? So this is basically a very quick summary of how they work. So now DDPMs versus GANs. One second. So here, in the first slide here, this is from the first paper that was implemented by Google, that's SR3. Now SR3 was compared with other existing models here, in case Pulse and FSR GAN. And they conducted a very, basically what they conducted was a 2 alternative forced choice experiment where the subjects were asked to choose between reference of high resolution image and the model output when asked the question, which of the image would you guess is from a camera? And based on the answer of the people, these models have been, rated. And as you can see, a lot of people have confused SR3 to this. And as in the slides, I will show you rightfully so why. So this is basically the entire comparison of SR3 against in depth. So the main, what do we say? So the main, this thing that has been used is FID. Now FID stands for Frischet inception distance, that in very simple words tries to measure the distance between the generated image and the original sample. And usually lower is better. For our references, lower is better. That's what I like to say. And in the second model, that is the cascading diffusion model, FID scores were actually quite lower as compared to BigGAN as well as ADM. So now I would like to show the real world implications of this before moving to my research topic. So this is effective super resolution. So as you can see, super resolution has been applied to Jeffrey Hilton's face as well as a cheetah. Unfortunately, for the rest of the examples, I could not find this cheetah. So all rest of the examples are built on Jeffrey Hilton's face. So I have used other two GANs as comparison, that is ESR GAN and Pulse. I couldn't find FST GAN's weights, so I substituted it with ESR. So here we go. So basically ESR GAN before we go, I would like you to quickly take a quick notice at the eyes of Jeffrey Hilton and SR3 and eyes as well as the hair, and look at the amount of details it produces. Now comparing that to ESR in the same region is barely trying to struggle here. And this is where you can see people actually confusing themselves between SR3 and other GANs like FST and Pulse. Now, Pulse had a very weird result. It changed Jeffrey Hilton's face entirely. Like, this is the best reconstruction that I could personally get back. Half of them ended up looking like a woman, unfortunately. So even here, as you can see, the details of hair and eyes are totally messed up. So where does this all lead us? The research going forward, the work I'm trying to do is heavily inspired from a work done 3 years prior with, one second. Sorry, Yeah, so it is heavily inspired from a work done 3 years back, which is on basically deep image priors, which took CNN models, and without showing them the actual image, they were passed through a corrupt image, and they could reconstruct it back. My argument here is that DDPMs will not only be able to reconstruct it back, but will also be maintain the original, will be relatively very close to true image to a naked eye. So this is where my research going forward is. Right now I'm creating this data set manually because so far I couldn't find a data sets pertaining to these two problems. So the way I'm going ahead personally is creating this data set by myself, creating a bunch of classes and then passing it through CMD. And then measuring the FID distance between that particular generated image and the original uncorrupted generated image. And this is the direction of my research going ahead. So this is what the kind of work I want to do. And before I conclude, I would also like to talk about the real world implications of this. So the most common fields that use image super resolution on a lot of bases are your apps like Photoshop and basically all of your image editing apps. So I went through the Photoshop subreddit to find the issues that they had with super resolution. And I found one really interesting, which kind of pertains to all of this research problem. This is a problem that was raised by someone a couple of years back, who basically just said, hey, dude, I'm trying to work on something, but on a 360-degree camera, but the images are coming out really hazy. And reconstruction of that image back into the Photoshop model in order to super resolving it was not possible. And the only solution this guy got was basically added more work to his original work. Wherein I feel DDPMs can really be successful because of their capability of being so lightweight, as well as able to, be easily trained and reconstruct the images back, is to actually help users like them to ease their work. Like rather than dividing it into multiple sectors, this could have been passed on as one image and could be reconstructed back with with a very high capacity. I feel that DDPMs are way more sustainable, like they are way more, the right word would be flexible to real world changes as compared to GANs or V8s. So this is where I end. Before I conclude, these are the references for all the beautiful images and the GIFs that I used, along with these two references basically explain the models as well. And the last two are the research paper blogs written by Google that also lead you to the research papers. Lastly, I'd like to thank Swapnil and the entire team for being such a marvelous support, because my team left in the middle and yet they continue to support me with it. So it has been an amazing journey. So thanks a lot, everyone. So this is where,
Right, we can move to judges' comments and questions. Karan, you can start.
Yeah, I can go first. Again, great presentation. Loved the enthusiasm. It was awesome. Yeah, I had a question about the last part, about Photoshop specifically. So first question, I think, was, do you have an idea as to what model Photoshop uses for super resolution?
None that I have seen of. So the reason why I could not approach even other companies like NVIDIA as well, because NVIDIA has, apart from this, gaming also has them use case. But usually I have not seen much chatter about it. So this was the only open information that I have about any model. So I'm guessing a lot here. Yeah. But yes, it might be a VA, because that's what NVIDIA uses for their gaming sector. It might be.
Okay.
So there is not at least that I know of. Yeah.
Got it. Okay. And on that similar note, then, why do you think that a DDPM would perform better compared to the other models on a 360 image? Like what makes it, I guess, what is the difference between a 360 image versus a normal image that makes DDPM more suitable for images like that?
So when you're, so the way I saw this problem is that when you work with a 360 image and you're passing it to Photoshop, anyway, you have to divide the images. An image might not be perfect, right? There are artifacts from the camera and all of that. And the way the other user described his answer, it was very evident that this super resolution algorithm was struggling with the above said artifacts. Wherein I am sure that DDPMs will work better is also based on my trust in the paper which I just showed on the priors. It is also and it's basically the overall performance in comparison to GAMS. So basically what I mean to say by that is this is still to be tested, but I'm pretty confident in my results.
Got it. I think it would be helpful if you actually took a 360 image, run it through Photoshop, run the FID algorithm to calculate the difference, and then also run the DDPM algorithm and see if you're performing better on FID. And I mean, that would be a very compelling result. I know, of course, finding that large data set, and so Photoshop is a very intensive application. That would be hard, but I think even just a couple of samples would have been a step in the right direction. But yeah, I think that's it from my side.
Perfect.
Yeah, thanks for the great presentation. So I have a question. So I'm not entirely certain. So SR3 is a fairly similar method to what I guess you are proposing. I'm not entirely. Could you explain what is exactly your what's the difference?
Okay, I get your question. So basically, if you look at all of the recent DDPM researches, they are more or less the same, but slight variations here and there. So what I am proposing is more of a implementation here rather than a new algorithm. I hope that answers the question that you're asking for.
Yeah, I think I'm not entirely certain that it's anything new if you're just sort of, using the same diffusion method there.
Okay.
In comparison to SR3, you might want to check that out again.
Yeah, that's
it's more or less sort of an application towards that end. Also, keep in mind that even though on the examples that you showed in the super resolution task, it did perform better, but BigGAN still beats SR3 on actual conditional image net generation by like a 4 or 5 FID points, which is like a lot.
Yeah, I get that.
So
I know you've worked personally with this, right? I read a research paper of yours. So I know you've worked on this personally. So fair enough, I'll take your word for it.
Sorry, so just circling back to Karan's point, I think, it's probably not very obvious why one method will work over the other. I mean, especially on the subset that he's mentioning, or the subset that you mentioned. Just might be worth looking into that direction. But great direction otherwise. Yeah, I really like the direction. And your intuitions are all like great, like really in the right place to sort of use this diffusion width method to do super resolution. That's a great idea.
Thanks. Yeah.
All right. If that's all the judges' comments, then we can move to the next team, which is Namespace.
Yeah, so I will start presenting.
Please bear in mind time again. Just
yeah, of course, yeah.
Thanks. Hello, can you hear me? Okay, I think I can hear myself. Great.
Wait a minute. Yes.
The team after this will be Twitter bot, so please prepare accordingly. Take it away.
Yeah, is the presentation visible?
Loading now, but yeah, it is visible now. Hi everyone, we are the Namespace team. Today, Tanish and I, Shrey, myself, will be presenting today. Our presentation is Don't Get It, aka the sarcasm. So it's a sarcasm detection. Next page. Yeah, so our motivation, sarcasm has been growing a lot, especially on social media. We've seen it every day. We actually used it. Maybe we had a time that we don't get it. Maybe there's a time we get it, So it's either funny or sometimes it can be offending. But it's been catching user attention more than, normal text that we've been using. And then it has a fun element to it, and we've been using it for some time. And even then, it been using a marketing strategy lately. For example, Zomato, they've been using sarcastic kind of messages through pop-up notifications and other. Next slide. So our problem definition, it's very obvious, like we all are very familiar with this topic. So in sentiment analysis, usually we analyze the text and then we can actually tell it as positive, negative, or neutral. But for sarcasm, it's kind of like not that straightforward. Even in human setting, like, it's kind of hard to grasp someone is being sarcastic or not. So we have to know some sort of like contextual knowledge. So this is kind of like where our problem definition goes. So we like to work on this problem. So in this, we are approaching in 3 different ways. So before talking about deeply, let's talk about related work, because this is not new research work. It's been here for a few years now. So the first one, it's a classifying sarcastic comment on Reddit using word embeddings. So in this paper, it's not very that complex compared to another one that we're going to be presenting. This one, they use the various comment as a input, and then it's like a high dimension vector, and then they go through the like a few classification models and then 2 classifying comments, and then they also talk about like embedding word embedding model, and then they compare traditional text classification technique and then like word embedding model by using backup and grams representation. So on the right side, you will see, that's how typical, not very typical, kind of like word embedding that they used. And in this paper, they were not actually mentioning about like any accuracy score or any F1 score, or any kind of like confusion matrix. They only mentioned about validation error rate, and then in that they said simple, vanilla, naive based classifier using unigrams and bigrams work the best. Next page. Second paper that we were referencing is sarcasm detection using multi-hat attention-based bidirectional LSTM. So in this paper, they went through a really great resource, and they actually started introducing feature-rich SVM model. After that, they actually introduced the like MHA by LSTM. So here on the right side, you see how their model is laid out. Firstly, they will be like going through a word encoder and then, attaching them to multi-head attentions. Later, using the sentiment embedding and then concatenate them, and then later outputting either their sarcastic or not. So in this paper, they were actually mentioning about a lot of, confusion matrix, a lot of like comparison of like different data set, not different data set, different approaches on like the data set they were using. So like you see, MHA by LSTM has the best, or seems to be having the best F1 score, and also like precision score. They were hitting 77.48% and 56.79 if they were unbalanced data set. Next slide. So what data do we use for this project? Kind of mentioned a little bit in the beginning, we are using sarcastic comment from Reddit, and then the data that we get is from Kaggle. It's already scraped from somebody else, and then it has 1.3 million comments. And then how it is scraped is, I think everyone is familiar with Reddit, I guess, and then it has a sarcasm tag, which is like /as, and then they scrape out most of the stuff from, or all of them from Reddit, and then it has a true distribution with true ratio of 1 to 100. Yeah, next slide. So this is kind of like a, like a view of what the data look like, but we are not using all of them in our project this time. We are only using label and comment. So we not even using the parent comment. So we are just using normal comment and label. So 0 means it's not sarcastic. 1 means it's sarcastic. So we are using that part of the data. Next slide. So before we go through the training or anything, so we try to do pre-processing, cleaning the data. So we try to remove stop words by using Porter stemmer, and also we remove unnecessary tokens, punctuation, URLs, mentions, hashtag, like these things that would be very helpful for our training by using regression expression. And then we also did tokenizing sentences and petting the sequence. We also use vectorization, in this case TF-IDF for certain neural network that we are trying to train, not in all. Next, we will be talking about our approaches for this whole project. Yeah, Tanish, take it away.
Yeah. Thank you, Shweta. So yeah, before talking about approaches, one thing I would like to remind is that the research paper that we refer to, they actually got good amount of accuracy and F1 score for at least balanced data set, like 71%. So why not use that model only? So two things, space and time. So when we first started running that model on Kaggle with full GPU power on, it actually took too much of time for training. And on top of that, after an hour or so, it gave an error called memory limit exceeded. So then we decided that our goal should be to design a model that is as efficient as that model, but on top of that, it should be space and time efficient as well. So this problem is basically binary classification problem, right? If the label is 0, then it is not sarcastic. If the label is 1, then the comment is sarcastic. So in that case, the first machine learning models that come into my mind were like logistic regression, naive Bayes, and gradient boosting, the most common machine learning models. So this was our one approach using machine learning models, and other approaches include deep learning methods such as a simple neural network, and the third one mentioned here, it is the model that is of great importance. We'll talk about that in detail later, but first let's have a look at machine learning models. So we basically played with, experimented with the hyperparameters of all the machine learning models. For example, for logistic regression, we changed the C value. That is basically the inverse of the regularization strength. So as we can see, as the C value increases, the accuracy goes on increasing. And after the certain value, that is 5 here, it decreases. A similar pattern can be seen with the change in alpha value for a multinomial naive Bayes, and the n underscore estimator, that is the number of trees involved in the algorithm for a gradient boosting. Actually, when I trained the model with the higher values of n underscore estimator, that is 1000 or 2000, it also gave better results, but once again the time requirement was high, so it took too much time for training, and this is not that coherent with our goal. That's why we scrapped that idea. Just till 300 it's okay. Now coming to deep learning approach, here is a summary of the model. It is essentially very simple model. The first layer, that is embedding layer, which is the most important layer. It drastically decreases the feature space of the data. Whatever pre-processing we did, the output of that goes to the embedding layer first. Then there are certain like global average polling layer, which is important, and few dense layers connected to the output dense layer. And we actually use value activation for everything. One point I would like to mention is we divided our data in 3 parts: the training, the validation data, and the test data. So here is the graph of accuracy and validation accuracy and that stuff. And this is the confusion matrix for the simple neural network. Now coming to the main part. So, okay, we cannot use GRU. We cannot use multi-headed attention-based like bidirectional LSTMs and that fancy stuff. So one thing that caught my attraction was CNN plus LSTM architecture. So this architecture is actually used widely in image recognition, computer vision stuff. So can this be used in text data? Actually, yes. So the idea behind this, actually, one of the TAs explained how does this work for this model? How can this work? Basically, the idea is LSTM takes into consideration the data, the information from the starting of the current sequence till the current timestamp. So to basically break this pattern, we use the LSTM for getting a window-based information, the sequence-based subsequence-based information. And later on, we use max pooling layer after con1D, that is one-dimensional convolution. We use max pooling, which is basically used for helps in like extracting the most important features from the data, and that that output from the max willing then passes to LSTMs and generic dense layers connected to the output layer. And here also the activation function used is ReLU. Here is the graph for each epoch, and this is a confusion matrix. Well, so here is a comparison of the highest score that we got for each model, for each experimentation for each model. So logistic regression, as you can see, there is not much change if we change the regularization from L1 to L2. And so basically we know that the model cannot be judged simply based on the accuracy score. That's why we also calculated the F1 score and Jacquard score. So yes, multi-novel naive bias, the maximum accuracy test accuracy we got is 0.65. Like gradient Bush gave the maximum amongst the machine learning models. And the embedding layers, of course, as expected, are the clear winners. The accuracy score is highest, also the F1 score. And I would like to mention that we actually changed some hyperparameters for this also, like not hyperparameter exactly. We actually changed the optimizer from ADAM to RMS prop. Then we tried changing the learning rate. But the thing is, like, the data set is huge. So there are millions and millions of comments. And in real world also, there are even more comments, right, for training. Yeah. So that actually did not help too much, like changing the learning rate and that stuff. We also like tweaked with the other hyperparameters for each layer of the kernel size for CNN layer. And
question about the last model, what embeddings did you use? Did you use pre-trained embeddings or did you just
yeah, we actually train the embedding from scats, so we can use like BERT embeddings and that stuff. But the thing is, like, first of all, we wanted to like, this is based on sarcasm detection, right? So what we thought is, if we train the embedding from scats, that will be better instead of using the pre-trained data.
Why do you think that's true?
Like, because wait, like sarcasm, the normal text generation is different. Like, it has a normal plain old English language general, and but for sarcasm, the language changes, you know, some words change. Some words are actually emphasizing that.
Okay.
Yeah, so that's why.
So I take that intuition, but I just want to tell you that the pre-trained, like if you're talking about like just co-occurrence based, you know, word to vec kind of
yeah,
embeddings, probably you'll still get a gain from that, because you know they're trained on corpora that have already included data, like text of the form that you're training on. They have also been trained on, like, you can find word to vec in whatever which has been trained on Reddit, for example, or like whatever data set that you're, yeah. And on the other hand, like for pre-trained models, like you said, you mentioned BERT, I was going to bring it up later, but suppose you only use like the embeddings as well. The other option is to use like the model and also fine tune it on your data. So even if there is some like difference between what data it has been trained on, and you think that, you know, sarcasm hasn't been like really understood in that data, it doesn't matter, because when you further fine tune it, like train it starting from that initialization, but you continue training it on your data, it will learn to use it. Like it will learn to adapt to it. So it's always better to, like, if you have data that is even remotely relevant and it's been trained, and these models have been trained on like large amounts of data beyond what you can like ever, you know, train yourself, then it makes sense to use it just like as a.
Yeah, got it. We did not take into consideration that point. Yeah, got it. Yeah, so yeah, that's basically it for our presentation. So to conclude, I would like to mention that sarcasm detection, the problem was, as Shway said, was there for quite some time. And actually it is extremely difficult for us humans also to detect the sarcasm, right? Sometimes it gets difficult for us. So it is expected to the machine learning models to underperform. Also, yeah, so we are not completely satisfied with the F1 score, even though the goal of the project, that is to make the model efficient in like for space efficient, time efficient, was met. Still, we are not satisfied with the accuracy and F1 score of the model. So we would like to improve on that in the future. Like as you said, we will probably use the different treated embeddings. Also, sarcasm is basically context based, right? If you do not know the context, then it is quite difficult to understand if this is sarcasm or not. So what we did is like context blind kind of training. So what we would like to work on in future is like we would like to take into consideration the parent comment as well, and the other features as well, like which subreddit it is. For example, politics may have more sarcasm. That might
I'm
depend.
going to ask you to wrap it up in about 30 seconds because we're like seriously over time for the other teams. Sorry about that.
Yeah, I'm sorry. Just one last point I'm going to mention anyway. Sarcasm is basically similar to, I think there is great correlation between the sarcasm and contradiction detection. So what I was thinking is, can the model trained on sarcastic comments data be used for predicting the contradiction in the comments? Yeah, so that was the last point I wanted to discuss. So yeah, with that, I would like to conclude the presentation.
Cool. If there are judges' comments, I would really appreciate if they could be made quickly.
I have one or two which I'll make very quickly. If you care about making it more efficient and less in space, then that's another reason to also use subword tokenization like BERT, because it has a bounded vocabulary size and you have like less chance of having OOVs, basically because you don't always I don't know how you're tokenizing, but if each word is one word in your vocabulary, you have like some limit on the number of words you can keep, right? But if you like tokenize at a subword level, you can cover more vocabulary. So that's also a good idea to reason to do that. And I guess this is really nice that you've tried so many different things. But of course, we want to learn more and like try the new things that are happening right now. So I'm just going to like give a plugin for like Hugging Face Transformers. It's a library which has amazing support and like really good and clean code for anybody who's very new as well. You can just read through their code and learn a lot. So I would suggest you like try going through that and maybe use, it's very simple to like use pre-trained models like BERT, for example, directly off the shelf. They have examples, they have a tutorial. So I would start looking, like if you're interested in NLP and like, you know, sentiment and sarcasm and all of this stuff, it's like really important that you learn the tools that people are using right now. And I think this is like going to be a very important tool to have in your like tool stack. So you should check that out.
Yeah, thank you.
So we can go Mauro and then Akash.
Super quick. It was a great presentation, but I see that it's missing like the comparison against, you said that you wanted to make it faster and smaller and potentially at the same quality of the big machine learning models that you couldn't run locally on your machine. I don't see this comparison, neither in performance nor in model size, MIPS, watts used, whatever. So I think that this is really the only missing part of this presentation.
Oh, got it.
The rest was great.
Yeah,
the second thing is that if you want to go for smaller models, this hits quite close to home to what I'm working on lately. The other option is to go with distillation. So you take the big model, you take a small model, and you just try to learn what the big model learns with the small model. And it was found to really help because basically it discards everything that is already noisy, etc., and it helps building smaller models.
Yeah, got it. Understood.
Done.
Yeah, thank you.
Super quick. Yeah, like really good presentation. I'm like I only have one comment that I actually genuinely like that you guys first tried out all the simpler SVMs and logistic regression, naive Bayes. That's like I cannot like it's like I'm out of work. But this is great, like really good to see that you're actually doing this and then actually finding out that the model that you did try, the deep learning model, doesn't actually give you that much performance increase. And that's like you're in the right path. Like absolutely brilliant.
Thank you.
Awesome.
Yeah, like in this presentation, really quick, not presentation, like project, trying different things, even though we didn't actually, outperform anything, but like we learned how, how do we actually figure it out to Chum, even though we didn't figure it out yet, but like it actually helped us like to understand more, how do we use these things. So yeah.
All right, so I'm going to move to Twitter bot. Are you folks ready?
Ready to go. Just give me a second.
Take it away.
Host disabled participant screen sharing.
Yikes. Sorry about that.
I'm deeply offended.
Okay, you should be good.
Yeah, I got it. All ready?
Cool.
All right. Am I audible and is my screen visible?
Yes to both.
Alrighty. So I'll go ahead and get started. Hi, everybody. My name is Joe, and my project partner and I are going to go over our project, which was gathering and classifying sports injury data, specifically for baseball, but in the future, we will branch it out to other sports as well. So here is a quick problem statement. We want to create a function where we take in a tweet and we have a target output. 0 for the statement is not a statement about an injury, and 1 for this is a tweet that is stating an injury. And I have 2 examples there over on the left-hand side. So the first one is a ballpark engagement gone wrong. That's not the kind of injury we're looking for. We're looking for physical ones, not emotional ones in this case. So that pops out as a 0. And the one on the bottom, a trainer is coming out to take a look at a player because they hurt their right leg. And that is an example of an injury report. So we want that to pop out as a 1 instead. So this is left over from a earlier project I did, and this is kind of an idealized version of what our future work would look like. So this is from a project I did in 2020. On the left-hand side, there's a player ID number. There's an entry type for whether this person is added on this roster, currently on this injury roster, or a little bit out of view here, whether or not they're removed from the roster. There's a description of what the injury type was and when they're expected to come back, and a little bit of like updates if there were any along the way. So the reason I want to use machine learning for this model has to do with the way baseball is structured right now. So in that project, I was able to automate all of that via web scraping, but that was all at the very top of this pyramid at the MLB level. That's all that information is public. It's not necessarily nicely formatted, but you can web scrape and create that spreadsheet, and it's fully automated. For the rest of baseball, which is AAA and all the way down to high school, that information is much more privatized. And so it's very difficult to get a full data set. So I believe the reason teams are doing this is because they're trying to keep a trade advantage, or they're just trying to keep their analysis private so that they might have a little bit of a research advantage. And so if you want to do any long-term research on, like, say, how to appropriately do rehab, or how this injury might cause a player to need to switch positions, it's actually very difficult to do because the sample size is so low if you're just using MLB. There's about 900 players in MLB. But if you can actually expand the leagues that you can do this with, you would actually have over 9,000 samples to work with at any given point in time. And that's a much better way to study. So the long-term goal of this is to collect enough data and have it be accurate enough that we could hand this over to a statistician in 3 to 5 years so that they can do a much more proper analysis. So These are two other considerations for a project with respect to limitations of data. So getting labeled data is rather expensive. I have to hand label all of this. So ideally, we'd like to use both labeled and unlabeled data. So that makes this a semi-supervised learning project. Unfortunately, we didn't really find an algorithm that fit our use case with semi-supervised learning. Like co-training was one of the ones that we found. It doesn't really fit our use case because the way you would have to use co-training is that you would have to split up all of the words in the tweets and then hope that two separate models could work on just half of the words. And unfortunately, that doesn't really fit our use case. And there are better ways to do this as well. After that, we don't exactly have a case of online learning, but we do want to be quick. We do want to not miss any tweets. And so ideally, we're able to repeatedly kind of run this every day. And so that we can quickly classify things and label them and then get them onto that spreadsheet. So this is a quick outline of what the web scraping pipeline looks like. Firstly, I'm picking up accounts that I might want to track from those account scrapers on the left-hand side. There's three of them: SportsSpider, RotoWire, and NBC. And from those sites, I get Twitter accounts that I want to follow. And then I use the library twint in Python in order to actually get the tweets that I would like. After that, I do a little bit of hand labeling, both from the tweets that are being picked up from twints, and also there are a couple of positive case tweets being labeled already by NBC and RotoWire, so I take advantage of those. And then lastly, that's all formatted and cleaned up into a CSV file that we can work with our machine learning algorithms. So as of this writing, there's as it says on the bottom, 2,200 accounts that we're following. There's 600,000 tweets, although a lot of those are retweets and duplicate pickups from twints. If we actually go and clean that out, there's about 15,000 unique labels. And among those, about 1% of that is actually the injury reports that we would like. So there's a pretty significant class imbalance that we're working with as well. So here is our results with just using standard models. This is using all of the models that you would find in a machine learning class where neural nets is not the specialization. So in the interest of time, I won't go through all of them, but I will quickly explain that TF-IDF is a weighted frequency data type. It's continuous. Boolean is a coin toss type. It's just 0 for the word is not present and 1 for the word is present. And count is the integer count of words that showed up in a tweet. And so we did 8 full cross-validation using the sklearn library for all of these, using grid search DB to find the best model parameters. And these are the results of all the best model parameters. We also did use stratified sampling to help a little bit with our class imbalance issues. And we used stop word removal and word stemming from the NLTK library in order to reduce the dimensionality a bit. So of all these models, one last thing I want to point out, sorry. I looked up in PCA as well to reduce dimensionality, just so that I could get other models, like say a simple dense neural network, to be part of the mix as well, but it didn't really fit to our use case. When I tried to use the variants of PCA called IPCA, the approximate method that avoids a little bit of memory issues, it did add a lot of computation time, as in it took like 16 hours to run in order to compress the data. So unfortunately, it doesn't really fit for a use case because we want to be under 24 hours. It already takes 15 hours to web scrape just due to having to respect Twitter's policies about scraping data. And so if I added that, it would take 31 hours at the minimum, which is not so great. But after that, of all those models, the best was the multinomial naive Bayes. The reason for it is the false negative rates. And the reason we're trying to minimize that is because in our use case, once we get our model, I'm going to use it on, like, say, 100,000 unlabeled tweets, and I'm only going to see the outputs that came out as 1. So that's all the false positives and all of the true positives. I can quickly label and fix those, and so that can become both new learning data for the model and also be information that we put into that spreadsheet. But I'm never going to see the false negatives out of the 100,000 tweets I picked up. So our goal is to minimize that as much as possible. And these all worked fairly good, but they all had a rather high they all had a rather high false positive rate, and they all have a little bit of a high false negative rate. The reason for this is, I believe, is because it's picking up keywords, and these keywords are kind of throwing things off. By keyword, I mean like the word hamstring or the word ligament or just literally the word injury. People don't really use those kinds of words in a tweet unless something bad has happened to somebody. But there was a very common example of a false positive that popped up where a fan had a seizure in the crowd. And I think what's going on there is the keyword seizure is being picked up, so it's immediately being thrown into one place. But it's not; these models are not picking up the context that it's a fan in the crowd and not a player. And so I think that's going to be a permanent limitation with these types of models because there's not really any mechanism in order to add that context in. So I'm going to hand this over to my project partner who did this project with neural nets instead, and he will show how this added context allowed us to improve our results a bit.
Hi, this is Jagrut Lalwani here. And here we used Hugging Face Transformer library. So we used the classification model class and we used the models, we also used LSTM and GRU model, and you will see the results for those in just a bit. So here we use, since we had a very skewed data set, we had around 7,400 data points in total, out of which we configured the data set in this manner that 1,400 data points were having true injury report, that is the injury, the target value was 1, and we sampled the other non-injury report tweets to around 6,000 so that we could manage the skewness a bit, and basically we downsized we sampled the target value 0 tweets just to get an understandable accuracy and just to compare the models better. So we also used stopword removal and word stemming, and we also stratified train test split on injury report just to make sure that we have the same ratio of target value 0 and 1 data points in both the training and the test set. So the results here on the screen are basically on sensitivity. So it is equal to true positive upon true positive plus false negative. So as mentioned by my project partner Joseph, we are just focusing on reducing as many false negatives as possible. So here ExcelNet is clearly performing best compared to DistilBert is not it is pretty close to ExcelNet, and after that comes Roberta and XLM Roberta. Now the thing is, I feel that with XLM Roberta, the accuracy is dropping to very low compared to the others, is because for XLM Roberta we had vocab size of 250,000, whereas the vocab size for the other three was close to 30,000. So possibly that is causing accuracy issues there. And as far as ExcelNet is concerned, I feel that due to its modified language training objective, which learns conditional distributions for all the permutations of tokens in a sequence, that is falling into our advantage. Also, that DistilBert, being a distilled version of BERT, retaining the 97% performance of the original BERT, whereas we are using only half the number of parameters. So it reduces the testing time pretty much, and it is retaining only half the number of layers as Google's BERT, and still it is performing equally well compared to ExcelNet. Could you please move on to next slide, please?
Of course.
Yeah, so these are the basic configurations, these are the standard configurations which were offered by Hugging Face, and we did not tweak them a bit due to time constraints, as we finalized the data only 3 days back. So yeah, as you can see, the vocab size for the XLM Roberta was 250,000, whereas for others it was close to 30,000, in the range of 30,000 and 50,000. Yeah, next slide, please. Yeah, so here we have also added the accuracies of LSTM and GRU model. And LSTM and GRU model are performing again a little bit well compared to the XLM Roberta model. And ExcelNet is performing the best among all. And ExcelNet's evaluation is in contrast to the BERT's masked language model, where only 15% of the only masked tokens are predicted, and this is also in contrast to the traditional language models, where all the tokens are predicted in sequential order, compared to a random order which was introduced in ExcelNet. And this is probably helping the model to learn bidirectional relationships, and therefore it is handling dependencies and relations between words much better compared to the other models. And the transformer Excel, from where the name Excel comes, is also used in ExcelNet as a base architecture, which also helps in improving the performance even in the absence of permutation-based training. Yeah, so this is just the diagram of ExcelNet architecture. Yeah, you can go to the next slide. Yeah, so as far as the future scope for this project is concerned, we are planning, like as and when we reach a good threshold of data set, we would probably extend this idea to categorizing the injury types, like identifying from the tweets which type of injuries occurred, like shoulder injury, left arm injury, and etc. And then we can also extract the nouns from the tweets, specifically the name of the team if mentioned and name of the player if mentioned, using the Spacey library. And yeah, we could extend it that way. And we're planning to create a website where we would put all these results periodically. Thank you very much. And thank you to Swapnil and all the TAs for giving us this opportunity. And thanks a lot to the judges being here and analyzing our evaluation. Thank you.
Awesome. You can move to judges' comments, if there are any.
I just want to say, like, great work, like, so thorough. I'm very impressed. It's covers everything you guys. I mean, yeah, I know what to say. It's just, you covered all bases. It's very well thought of. Things are analyzed very well, motivated very well. You're checking for things when they're not working. It's like how scientific study needs to be done. So brilliant work. That's all.
Thank you.
That's one. Don't have much more to say. It was really nice.
Thank you very much.
Very much, yeah.
I think that's it. Oh, yeah. Cool. All right, so we can then move on.
Karan, Swapnil, seems like Karan has something.
Oh, I think he clapped. So.
Yeah,
oh,
it was just a clapping hand.
Sorry.
Thanks.
There's
cool.
no questions?
Thanks.
Oh, okay. We did a perfect job.
Indeed, yeah.
Cool. All right. Well, I had one question. I forgot what it was, but I'll bring it up again. We can.
Sorry, just wanted to say, if you can think of it, you can post in the chat and I'll take a look.
Exactly. Yeah. Sorry, I forgot about it. It was very early on in the presentation. Never mind. We can move on to the next theme, which is hyperparameters. And then we have the last theme, which is Bratz hyperparameters. Do you have screen sharing permissions?
No. Could you make me the co-host?
And Bratz, if you don't have screen sharing permissions, please also ping me.
Yeah,
sure. Should be good.
Yeah. Wait,
Audible, and we can see the screen.
Yeah. Cool. So one of our team members, Sai, is not present today due to some commitments. So I'm Janvi, and my teammate Chelly would be presenting our idea. So we have already recorded our presentations. Yeah. So let's quickly start it.
Hello all. I'm Sairathik, and we are Team Hyperparameters working on the project Dengue AI, where we try and predict the spread of dengue in the cities of San Juan and Iquitos. We chose this problem as it is related to the aspect of global health that can improve lives of people in affected countries. Dengue is an infectious disease and is sometimes neglected by some countries. It is estimated that around 500 million cases of dengue arise in Latin America annually. We are motivated to help solve this life-threatening problem by modeling the relation between various climate features and the dengue dynamics. Our final goal is to predict the number of dengue cases in San Juan and Iquitos based on the features like temperature, precipitation, vegetation, and more.
Thanks, Ritvik. I'm Saili, and let's discuss some of the recent works in this area. The work done by Anuranjan MB and others in 2019 aimed at designing two time series based nonlinear regression models and data manipulation techniques using different parameters such as temperature, vegetation, and rainfall data. They also incorporated dimensionality reduction with time series modeling for better prediction of dengue outbreaks. They presented three techniques specifically: interpolation, random forest regression, and gradient boosting regression, and performed hyperparameter tuning for selecting the optimal performance model. Models were compared using mean absolute error. They concluded that gradient boosting regression performs significantly better than the other models. Recent works of P. Mohiltini and others in 2018 proposed a dengue possibility forecasting model. The dataset they used contained information about the number of dengue cases observed every week for several years in many countries. It had details about weather conditions like temperature, precipitation amount, humidity, and so on, using our GBR to find the pattern and dependencies in the given training dataset and predict the number of dengue cases of a country for a given week and year in the test dataset. Another study in Sri Lanka in 2014 used past weather patterns and past dengue cases as inputs and introduced an artificial neural network to predict the dengue outbreak in Kandy district. Moving on to the dataset we used, we were using a dataset from a hackathon on drivendata.org. This environmental data was collected by various US federal government agencies, including the Centers for Disease Control and Prevention and US Department of Commerce. The task is to predict the number of dengue fever cases reported each week in San Juan, Puerto Rico, and Iquitos, Peru. The dataset had the weather features for each week, including the minimum, maximum, and average temperature, diurnal range, dew point, total rainfall for precipitation values, mean relative and mean specific humidity values, and levels of vegetation in northwestern, northeastern, southwestern, and southeastern quadrants of the city as measured by satellite imagery. I hand it over to Chanvi to go over the methodology for our problem statement.
Hi, I'm Janvi. Now coming to methodology, there are two things on which the number of dengue cases depend on. One is the environmental conditions and second is the month or season of the year. So for that, we have divided the task into two models. The first model should capture the time series nature of the data. For this, we have a simple linear regression model which is trained on only the single feature, that is month of the year, and the output is the number of cases. Using just this model 0, we were able to achieve an MAE of 26.5 and we expect to decrease further when we include the model 1. The plot here shows the actual number of cases in San Juan and those predicted by model 0. A similar plot was obtained for the Iquitos city. As it can be seen in the graph, that the model predictions are periodic, which is fair given that we are yet to consider the environmental data. So for the outbreak or peaks here, we need one more model that would be modeling the residual of the actual cases and the ones predicted by model 0. So the final number of cases would be a summation of the number predicted by model 0, that is capturing the time series data, and model 1, which is capturing the outbreak or the peaks. As a part of future work, we are still working on selecting which features work the best and study the correlations between the environmental variables for predicting the outbreak by model 1. Besides, we want to experiment with various rolling windows. We are assuming that not only the present week, but also the weeks or months before
could impact the number of cases. Also, we want to try sequential models to take into account the previous data. So, thank you everyone. That is it from the team Hyperparameters. Thank you.
That was nice, short and sweet. We can move to the judges for their comments.
All right.
So, okay, go ahead.
Sorry, you want to go, Mara, first?
No, it's the same. Go ahead, please.
Yeah, just want to say thanks again. It's really good work. I really like the idea of that you guys took of modeling the periodic, the sort of the dependency on the season and the month separately, and then considering residual modeling. It's actually a pretty standard technique back in the day when you had models that were modulated with some hidden Markov process. So it's really nice to see that you're not directly just throwing some deep model at it and then hoping that will work, because you'll gain a lot here in terms of explainability. You know what the model is doing, why it is doing, which is really, really good in problems like this. So yeah, very, very good plan and really important problem to tackle.
Thank you.
Can you just mention your dataset sizes, like how many years have been surveyed? Is it only in one go, or you have different times?
So for for one of the cities we have 960 weeks, and for another city we have I think 540 weeks.
And those are all continuous?
They're all continuous, yes.
Okay. Also, can you give some hint on how, I mean, given that you are referring to some hackathon, how did it compare with solutions that were already presented there?
We didn't get our final results from our model. We're still working on a few statistics, but like the baseline model is as expected, it wasn't performing well. Like we got a very high error, but
yeah,
we expect it to increase.
Yeah, no, but just to get an idea, even if it doesn't perform as well, it doesn't matter. I mean, I would just like to get a feeling of what's out there and what's the solutions there. How do they perform? Do you know?
Yeah, like there are a few GitHub repos by a few participants who have shared their who have made their code open source, and yeah, like as in what exactly are you expecting?
I'll help there. Somebody just sent the competition link. Apparently the error rate is around 10 for the best model right now.
Okay. Yeah.
So I was going to tie this to a couple of things in terms of the way the plots you showed us in the beginning, actual versus predicted. There were some major spikes. So I'm wondering if there is like heterogeneous data you can actually collect or look up. You know the exact point at which the spike occurred. So was there a particular temperature? Was there a certain policy that the government implemented? Some reason for those spikes, and like going more towards like what Akash said about explainability, tying these kinds of models to decisions that might like affect the dengue rates. I don't know if that's a good direction or plausible direction, but I would think of like social problems as you can go deeper than just predictions and accuracy on these kinds of things.
You know, there's like prior work where they're modeling sort of occupancy in some building in Stanford. I think it's called Poisson modulated hidden Markov. It's a very old paper, but the idea is basically similar. You have a base model, some sort of a Markovian model, and then you have a Poisson process that modulates it intermittently, like so something very similar in your case, and then you know exactly why the firing rate goes up.
Oh, we
That
looked
was just
into
a
it.
comment. Yeah.
Okay.
Cool. I don't remember if other judges had comments. Sorry. If none, we can move on to the last set of presenters, which is Team Brats. And before that, I would ask the judges to share the link to your grading rubrics for me so I can start tallying the scores. You can send it to me on DM, Slack, email, whatever you like.
Can I
Cool.
start?
Yeah, you can start sharing, please. Thank you.
Yeah. So my project topic is brain tumor segmentation using attention units. Yeah. So what's brain tumor segmentation? So the main aim of brain tumor segmentation is to portray the regions of brain tumor with the relevant marks. So we have given the MRI scans of brains, and we need to portray the pixels which have the different tumors. So the aim of this is that it can be used as a diagnostic test for the image. It can be used as a pre-diagnostic test for brain tumor segmentation, and it can also be used for remote detection of brain tumor segmentations, maybe in rural areas where the medical facilities are not available that much. So this is one of the sample data sets. As we can see, this is a T1 MRI. So basically, in short, the T1 MRI shows the water content in the brain. The T1 CE MRI, it helps to show the regions of anomalies in the brain, and the T2 one shows the water content as well as the fat content in the brain, and the FLAIR MRI. The FLAIR MRI can show the cerebrospinal fluid CSF in the brain, and this is the ground truth. And as we can see, the various types of tumors detected are the red one shows NCR tumors, and this one are mainly glioma tumors, and the yellow ones are pertumoral edema, ED tumors, and the green ones are GD enhancing tumor or gadolinium enhancing tumors. So let's move to the data augmentation part. So basically, as we all know, that data augmentation can be used to improve the results. The data augmentation can help in normalization as well. However, as these images are of medical data and we can't change the color, all we could do is we could rotate the images and not change any lightings or the colors. So what we could do for brain tumor data augmentations is we could use the horizontal flip, the random rotation where we could rotate the image by a specific degrees, the vertical flip, or the dihedral. So what dihedral does is it rotates, it does a random horizontal or a vertical flip of the image, and then it rotates the image to any one of the dihedral angles, maybe 90, maybe 180, or maybe 270 degrees. So that's the dihedral data augmentation. And one thing we need to take care is that along with the images, we need to rotate the masks too. So the same data augmentation needs to be applied to the mask. Otherwise, the results can get skewed, and that would be a big anomaly. So then what I did was I carried out the literature survey for this. So basically, the previous literature could be divided into 4 parts. So the first part is the CNN-based models. So various CNN-based models have been used, and some of the notable examples include single-path CNNs. These were quite computationally efficient, but didn't have much accuracy. Then we had multi-path CNNs, and with the advent of FCNs were also widely used. And some of the most notable examples in FCNs include UNIT and 3D UNIT. Along with this, with the advent of RNNs were also used for this part. Although RNNs were usually used for sequential process problems, variations of RNNs like LSTM GRUs were used. And the next one is deep generative models. So with the advent of GAN, generative models have been used. So what happens in GAN is that there are 2 parts, the generator and the discriminator. So here for this problem, the aim of the generator is to create the ground truth for the image, and whereas the aim of the discriminator is to discriminate whether the ground truth has been created by the generator or is it the real ground truth. So this has been one of the one of the recent innovations in this. And SIGAN, one of the variation of CAN, has actually won the BRATS challenge, an annual brain tumor segmentation challenge organized by University of Pennsylvania. So, and apart from GANs, autoencoders have also been used for the brain tumor segmentation. And another recent work with the increase of computational power has been the use of ensemble-based models for this task. So some of the ensemble-based models include 3D unit with 4 different fully convolutional networks and deconvolutional networks. And now let's talk about my method. So here, so what I propose is to use attention units for this. So here we can see the architecture of unit. As we can see, the unit has 2 paths, the downsampling path and the upsampling path. And what happens is, in downsampling path, there are regular convolutional networks, and these convolutional networks, and the image is passed through these convolutional networks, and it is downsampled. And after that, from the downsampled image, the ground truth is generated using the upsampling part. So deconvolutional nets are used for upsampling, along with, and sometimes the deconvolutional networks can be unreliable for upsampling. So one of the novelties of units was that it used skip connections. So what skip connections did was that they provided the information from the downsampling to the upsampling path, and then along with the deconvolutional networks, the skip connections was also concatenated, and then the results were obtained. So this allowed the units to train deep learning models on very little data. So this was one of the peculiarities of units, and this is why units were widely preferred for medical image analysis. Now let's come to attention units. So what happens in attention units is, in the deeper layers of the units, attention mechanisms are added to it. So what attention mechanisms do is that they can distinguish the background and foreground really well. So in the research paper, when they conducted some analysis using on the lung data set, the attention layer showed that they could distinguish the background and the foreground. So previously, the unit and other models couldn't achieve much accuracy on such data sets. However, with the use of attention unit, the accuracy increased quite well. And along with this, to counter this, previously people used ensemble-based networks. So an ensemble was used for identifying the foreground from the background, and then the foreground was passed through another network, and that included a lot of computational overhead. However, by using attention mechanisms, this overhead can be significantly reduced as the attention is applied only to the deeper layers of the unit rather than creating a whole network for it. So that's all by my side. I have done my research and I have been working on the implementation too.
Cool. In that case, we can move to judges' comments. Okay. Yeah.
I just want to again say thank you. yeah, it's a good plan that you have, and I think you've considered quite a like important problem here. I quite like the way you didn't just take the data augmentation and apply it. You thought about how that will interfere with this particular type of data. That's really good thinking. And your literature review seems to be pretty good. Yeah, I think it'll be good to see some numbers later. But yeah, so far the plan looks pretty good. It's an interesting problem.
Yeah.
Yeah, and good considerations there in designing the experiments.
Okay.
Cool.
Thank you.
So I think we can tally the scores and post it to channel later. I just had the last team to consider. But in the interest of everyone's time, since we've already gone half an hour over what was originally proposed, I would like to thank the judges, first of all, for showing up on a Sunday in very different time zones across the world, and for very, very valuable comments and insights. I'm sure most of the participants will end up using these very concrete suggestions to extend the research. And I would like to, I want to give you the opportunity if you want to offer general advice or comments to the participants based on what you've seen today.
If I can say a few general comments on these presentations, and they also came up during our comments. There is a general lack of information on the data sets. And I think that those are super important, because in real life, most of the time, the big improvements don't come from the fancier network or the fancier architecture, but they come from a better data set, a better filtering pipeline, a larger data set, and whatnot. So spend a bit more time presenting what is the data set that you are using, how big it is, and the second thing is that what metrics matter to you. And some of the presentations followed that pattern, some didn't. And this really helps people that may not be in the same field to understand what you really care about. Sometimes you may be false positive rates, sometimes false negative, whatever. So have that. And for literature, if you have some benchmark data sets, show performance against the benchmark dataset in the final slide, even if it's worse. It's important to show so that at least you get a reference. Otherwise, I have to scroll back and forth through multiple slides, and it gets a bit more tricky, especially in the presentation where I don't have the slides at hand.
I can add one thing to that. I completely agree with the data. I think another thing that's extremely important when you're presenting results across many different data sets, across many different models where the performance is very similar, is to show like statistical significance, because like we don't know if the reason why one model is better than the other is just because of chance, which often is true, unfortunately, in our field. So it's really important to, when you're building your research, the first few decisions are going to affect the next few decisions. So like knowing exactly why one model is better than the other, and if it is always the case when you run the experiment 5 times, when you run it on different splits of the data, is like super important. So like just general advice to like make sure you do that when you're reporting your results, just for yourself even.
Yeah, I think I agree with both of them. And just on the sort of positive side, I think you guys already did a pretty good job. Like undergrad work, this is just so good to see that you're considering, like, not just, I think some of you are definitely considering not just throwing a deep model, collecting a bunch of data set and just applying things off the shelf. You're really thinking about what the data is, how to tailor your entire pipeline, and you have a clear understanding of the pipeline. It's just really good to see that just this early on you're following these like core principles of how to conduct scientific research. That's very commendable. So don't change that. Yeah. I think it's just, yeah, I'm very impressed with the overall quality of the presentations. I don't think when I was an undergrad, I would have done something like this. So yeah, it's just good work.
Awesome. If those are all the comments, and I would just like to close with one major. So it's for most of the students coming into this course, based on their applications, they didn't have much of a machine learning background. So for me and for the TAs to see this quality of research coming out based on the fact that we didn't even have more than 1 or 2 weekly mentorship sessions. Okay. More than 1 or 2 weekly mentoring sessions. All of this was done on their own remotely through a pandemic. And it's been brilliant. Like I cannot point out any faults in the kinds of presentations we've given today. So really well done. And I don't give out compliments easily. So good job. Awesome. So with that, I think we can close the presentations. I have the final scores, and I'll double check them and post them to the channel in the next hour. So one point I should mention is all of the participants who did end up presenting, we're going to send you guys a separate email inviting you for more of these sessions that we conduct on the weekends. Try and, if you like, you can have mentorship for the projects you are working on. We also have some projects that we've started working on. And typically it's similar, like Unicode research follows a similar remote research structure. So the goal is just more long-term research projects help you out for your grad school applications or generally learn more about research. So more on those later. For now, I think that's it from my end. Thank you all for showing up and staying on. This is really cool. And thanks to the TAs, most of all, for supporting all of the work that people have done through this relentlessly, through day and night, building websites, writing docs, grading proposals, setting the exams. You all have been awesome. So thanks a lot. Right. I will see you all later. Thank you again to the judges, and see you all on Discord. Bye-bye.